Okay, I think we'll make a start. So, good afternoon or good morning, depending on where you join us from, and welcome to our latest webinar, Illuminating Your Perimeter. So my name's Callum Ryder. I'm the market manager here at Raytec. It's going to be my colleague Stephen who's going to be taking you through the webinar today. So before I hand over to Stephen, I just want to give you a few housekeeping rules. So just to be aware that all attendees will be muted for the duration of the webinar, but we will have a Q&A session at the end, so you can submit their questions to us. And you can do that via the questions section of your GoToWebinar panel. So if you just type those out and submit them to us, you can submit them to us as we go through. So please don't feel like you have to wait till the end. Just type them out and send them across as and when they pop into your head. And like I say, we'll come to those at the end and do our best to get through as many as we can. So I think that covers everything. So without further ado, I'll hand you over to Steve, and he'll pick up from here for the main content of the webinar.
Okay, thank you, Callum. Hello everyone. My name is Stephen Carell. I'm a business development manager at Raytec. So I think we'll just get started now. So we'll just quickly go through the agenda on what we're going to cover. We're going to cover why lighting's needed for perimeters. We're going to look at the different types of light available and why you might choose one over the other, how one can complement the other, and so forth. We're going to look at the quality and distance and how they affect each other. We're going to look at network lighting and the integrations available. We're going to go through the light and design tools, and finally we'll go through the questions and answers as well. So why do perimeters need light to see? So fundamentally, it's one of the first lines of defense. A typical high security site, it's going to use cameras to surround the perimeter, and you may also have several other devices as part of the system, whether that be PIR, fence sensors, and so forth. So for the cameras to be effective, it's absolutely imperative that you provide good illumination on the whole perimeter. So if you've got good coverage for nearly all of it, but you've got a corner that might be dark, or you've misjudged the light is not overlapping one of the cameras, essentially that could mean that the whole site is at risk. So I cannot emphasize enough that it's imperative to consider good lighting on the perimeter. Detect and deter crime is an advantage from using good lighting, and of course protect important assets. So let's look at now the different types of light available, and as I mentioned, how they can also complement each other. So we'll start with infrared. So 850 nanometer IR is probably the most, well, it's not probably, it's certainly the most common type of light used for a perimeter fence. I would say that to this day still we sell approximately 80 to 90% infrared compared to all other lighting for security applications. So just to give you an idea of the proportion of what we sell. It's zero light pollution as well. So if it's used in a built up area, there's no chance of it being intrusive or anything like that. The infrared is ideal for capturing images covertly as well, and it's because it's invisible, it's not going to alert or assist any intruders. So we'll look at the white light now. Colored images. So some perimeters may opt to use only white light, so they may want to keep the camera in day mode so they can get colored images 24/7. Colored images mean you're going to get more information that you would compared to infrared, such as the color of someone's jacket, the color of someone's shirt, etc. It may be multi-use. It may be used for multi-use. So if you're lighting on a vertical plane, that would be CCTV only. However, if you choose to illuminate on a horizontal plane, that would cover both CCTV and general area lighting. And to give you an example of this kind of setup, it may be white light colored cameras, so the cameras can remain in color to monitor the area. They might be only triggered by alarms though, but the same alarms might be used to trigger key zones for the staff and personnel to patrol. So we do projects in the UK for critical infrastructure sites where we need to illuminate a sterile zone at, I think it's 10 lux. So when the patrol enter the area, it safely illuminates, and when they leave, that light will then turn off. And obviously, because it's not on all the time, it's not as intrusive, and it's more energy saving as well. More often than not, though, the white light will be used in conjunction with the infrared. So once an alarm is detected, the PIR, analytics, fence vibrations, etc., are going to trigger that one. So it's event driven. It can be also used as a visual deterrent to ward off intruders, and also event-based verification. So you might be using the infrared, but somebody comes towards the perimeter or towards the site, and then you can trigger the white light easily from the user interface, and then you can determine if they are a known personnel or if they are an intruder. It does, however, have some limitations. So the camera is more receptive to the IR part of the spectrum. So that means that you're going to get further distance with the infrared. And if we're talking like for like in terms of power and wattage, so if you're using a 50-watt infrared, 50-watt white light, you're going to always go further with the infrared. So that does need to be considered when you're specifying distances based on what lighting you're going to use. Light pollution can be a problem, certainly in built-up areas. Obviously, if it's in an area that's built up and you've got a really bright white light pointing towards some other property, it's going to be intrusive. And it may alert or insist the intruder. So you could spin this two ways. So obviously, if somebody sees a site that's lit up quite brightly, they might assume that there's value in there. However, it may also cause the intruder to do the crime somewhere else. So most commonly, it is preferred as a deterrent. And what we find is, even though there's all this technology available to identify people, most of the time they don't want to go through that legal process of prosecuting someone. They just want to scare them off, so they do the crime somewhere else. So I'm now going to introduce the newest of the Vario family. That's the Vario 2 IP-PoE hybrid. Bit of a tongue twister there. So this one's great. It's an all-in-one solution, infrared and white light. I would say it's the perfect solution for perimeter surveillance. So one unique thing that you're getting, obviously you can see it's infrared and white light, but you're getting actually the same power and distance as you would buying two dedicated IR or white light. And with regards to price, it's pretty much half of that. And you're only using one cable as well, so it's a lot more efficient at doing the job that two units would do. So yeah, as mentioned, infrared and white light. So a common use for this would be, you could have the infrared controlled by the photocell, so it would be monitoring that, and the camera would be monitoring the site in monochrome all night. And then what could happen is, you could have some other device trigger the white light to come on, or some other device trigger it as a deterrent, all from the one unit. So now we'll look at quality and distance and how they are going to affect each other. So let's weigh them both up here. So we've got illumination distance, image quality. So we touched on earlier, perimeter fence lines, they're covering large areas. It is imperative that the whole fence is protected. So as I mentioned, you've got to cover every area. So when lighting is specified, we're going to normally recommend that the light goes further than the cameras are, the distance between the cameras. So if you're using, 50 meter between cameras, we're going to specify 60, 70 meters. That's also, it covers the area below the camera. So there's no dead areas, if you like. You can actually save some costs by using a long distance illuminator. So this could be, you could have one illuminator to cover multiple cameras, or alternatively, you could have less cameras. So you could have a long distance illuminator, a long distance camera. That's going to result in less columns, less cabling, and obviously less cost. And to give an idea of how far we can go, one of our Varios can go up to 500 meters. However, quality of light would be affected by this. So skipping too far ahead there. So yeah, let's say, for example, we are using this mentioned 500-meter illuminator. Somebody comes on scene at say 30 meters, they're going to be likely overexposed. But then if somebody comes on scene at 500 meters, the exposure is going to be a lot less on that as well. So these factors do need to be considered, especially if you want to guarantee a uniform light level as well. So yes, we can go very far, but sometimes it's optimal to use maybe a little bit less to get a more uniform light, depending on the requirements. And obviously, uniform light is essential if you want to prosecute as well as detect as well. And you're going to reduce the likelihood of false alarms, because if you've got uniform light, the peak and ambient light level are very equal. It means that you're going to significantly reduce the chance of getting false alarms. So this is an important slide I always like to talk about, is understanding distance and how people calculate their claimed distances. So it's one of the most important things that we talk about. Unfortunately, there aren't really any standards when it comes to certainly specifying infrared light. So this means that a lighting manufacturer is pretty much free to specify whatever distance they want on their data sheets, and no one's going to know. So let's say, as an example, Raytec product will go 100 meters. Somebody could take that data sheet, a competitor, and then they could say, okay, we are just going to say ours goes 120 meters. So if there's a person specifying the project who maybe isn't as knowledgeable on lighting, it may be that they assume that the competitor product goes further, only to then have the client install these units and then they are unhappy. And this scenario has happened a few times to us. I mean, ultimately we do get the business, but it's not good for the client because they've had to spend, you know, close to double the amount on their lighting requirements. So we have a guarantee. Our guarantee is that all illuminators will deliver a minimum light level on scene at all of our specified max distances. So just to show you what they are, for infrared, it's 0.35 microwatt per centimeter squared. For white light, it's 3 lux. I'm guessing that most people will understand lux more than the other. So just to give a benchmark to you, 2 lux, the majority of cameras are going to get a pretty good picture. And then similar goes for the infrared. 0.3 lux, depending on the camera chip size and things. 0.3, it's going to get a pretty good picture, but we always like to give a higher level. We like to underspecify our distances. That means that nobody ever complains about our product not doing what it says on the tin, basically. We have also created an industry first video surveillance lighting standard called POWERS. So this stands for peak power, overall power, width and angle, environmental, reliability, specification and features. So what this is, it's a resource that we would use to help consultants when they're writing lighting into a tender. It doesn't even need to mention Raytec. It's just mentioning things like these power levels, just to protect the end user, essentially. And that's any information on that will be available on our website. So I've talked a lot about, well, I've used the example of this 500-meter unit. So here it is in action. It's the Vario 2 I16 with a 10-degree lens. So we can see we had to do this on a small airport runway because, believe it or not, it can be quite difficult to find a facility that you can have power and have an open view of 500 meters. So we had to use this runway. So I don't know if you can see my mouse moving about, but the little dot here near the center, that's that image zoomed right in. So we're looking at these people 500 meters away. Infrared is covert, so they would have no idea they're being watched. And we can practically read the writing on the side of the plane there. And this again is guaranteed by our minimum power rating. So what you see here is a minimum, like I mentioned, 0.35 microwatt per centimeter squared. Camera analytics is a different thing when specifying lighting, because depending on what type of analytics are being used, you may need more light on that. So fundamentally, no light means no analytics. If you have low light, what that could mean is it means it's struggling to classify. And what it does classify might be at a low confidence. And then if you've got a noisy image, that might mean that you're getting a lot of false positives because the noise can cause movement and things like that, especially when the analytics have been trained to detect small objects. So yeah, just emphasizing again, very important to consider lighting, even more so when you're using camera analytics. Okay, so yeah, as talked about a couple of slides ago on that runway, so narrow angles are going to achieve greater distances. However, it is also important that you consider wide angles as well. So you're going to need wide angles for things like the corners of the perimeter. Certainly if they are a sharp corner, you may need to cover that wider area. Gatehouses as well. So more often than not, gatehouses, they are going to have a specification and they tend to totally dedicated to them. So with regards to the lighting side of it, you normally need much higher light levels because they are wanting to get facial identity, certainly on critical infrastructure sites, of the person entering and leaving the site. And also obstacles and problem areas. So these might be things that weren't picked up on the site plans or were missed on the site survey. So things like a wider angle could solve that. And ever since Raytec was established in 2005, this is the same message that we still use to this very day. The angle of illumination should always match the field of view of the camera lens. If you have an illuminator that has too narrow, you're going to get a hot spot. If you have an angle that's too wide, you're going to get wasted light and you're not getting the optimal performance out of your illuminator. And we can see the image on the left. This is one of our small 25 watt Vario units. We can see the different angles available and the distances that it achieves with each of them angles. So one of the features that the Vario has, physically, it has interchangeable lensing. So that means that you can change the angle to match the field of view of the camera lens, as talked about, how important that is. And the product it doesn't have a single moving part in it. So this completely reduces the chance of failure. One product can cover 10 to 120 degree. And it means that it can be used in several areas. So the example of if you're installing on a perimeter and then there's corners you didn't anticipate or obstacles, it's fine with this unit because you would just simply change the lens on site, which means it's absolutely it's brilliant for installers as well. So especially if they have got some units in stock or they decide they want to change the angle of the camera lens, they can then change the corresponding Vario angle as well. The next benefit of that is hotspot reduction technology. So what this does is it helps guarantee even illumination across the scene. It uses elliptical beams. The elliptical beam means that you're not going to fire any light into the sky where it would be wasted, and similarly it means that you're not going to get overexposure on the foreground as well. So we can see the image on the left is using a circular beam that's probably firing some light where you don't need it in the sky, but also overexposing the foreground. And then with the Vario, it guarantees even illumination across the scene. So we're going to now look at the advantages of using fully IP addressable network lighting. So hardware integration. So modern perimeter surveillance systems, they're often going to consist nowadays of several IoT enabled devices, which are intended to work together. Typically, these are going to include the IP cameras. These cameras might be working also with analytics. Then you might also be using PIR motion sensors and or laser detectors. So laser detectors similar to the PIR, but these can detect movement in certain zones and then tell the PTZ camera exactly where it's going to look. The fiber optic fence sensors as well. So they would detect the movement or vibration in the fence, and then depending on the system used, that would give a warning on exactly what zone has been compromised. And then last but not least, the IP illuminators. So for many years now, lighting was classed as essentially as an add-on accessory to simply turn off and turn on at nighttime. The network illuminators now allow these to be integrated as part of the full system, so they can complement one another. So let's say, for example, camera analytics could be telling the white light to turn on at certain zones. The PIR or fiber fence sensor could be telling the light to trigger as a deterrent. And then we can also look at the software integrations as well. So typically the specifier is going to they're going to choose a VMS system to manage all these devices. And here are some of the integrations that Raytec have. And it's important to note as well that the majority of these are plugins as well. So there's either no need for a license or there's a very small cost. So in terms of the extra cost for using lighting as part of the system, very low. So yeah, using the VMS integration with the Raytec, we can be even more intelligent. So I'm going to use the example of the hybrid. So what you could do is you could have multiple alarms. So you could have, let's say, certain zones are going to change the intensity of the IR depending on how close or how far the subject is. So if they're too far, turns the light up, and then you can recognize the person, and they come too close, turns the light down. So remember, I was talking about the 500 meters. If somebody comes on scene, they might be overexposed. This kind of allows flexibility to deal with that. And you could have other zones where they are triggered by a deterrent, or another zone could be triggering light to safely illuminate for a person to see. And these are just a few examples of so many that I could say on VMS. So what I'm going to do now is attempt to open another screen here because I've got a video to play. Just to note that the video does come on a little bit loud, so you might want to turn the volume down a little bit for the video and then turn it back up again when I stop it. It's about 30 seconds to 1 minute. Okay, yeah, I think I underspecified that video has been 30 seconds to 1 minute, but it was just a little bit longer. We're now going to talk about the lighting design service that is available to all our customers. So why is it important? So it's going to guarantee that, skip that bullet. It's going to guarantee that we're going to achieve the specified light levels across the site. So every single one of our white lights, they've been independently tested to extract the photometric data, and then this data is then used to produce replication of the real life scenario. We can do it using 2D and 3D. It means that there's no surprises at the point of commissioning as well. And it's also a great document for installers because it's going to show exactly where the light should go and where to point it, and essentially assure that no errors are made. So we'll take a look at the 2D and 3D here. So 2D, this one is great. It's great for plotting individual lamps and to show the direction of them. If you were to illuminate for multi-purpose, like I mentioned, on a horizontal, we could also add contour lines. So let's say that within a certain stereo zone, you want to achieve 7 lux. We could then put a contour line on the outside and inside, and that contour line would say 7 lux, and it would mean that within that sterile zone, we are guaranteeing you're going to get at least that light level. And then with regards to the 3D design, you can see it here on the left. This one's great to show the client exactly what they're going to get before single units being purchased or installed. In some occasions as well, we've created a nice walkthrough video simulation to show the client what they're going to get, bring it to life. Here we have a tank farm, and you can see, you're probably wondering why it's so dark on the inside, but we've done this on purpose just to demonstrate the harsh cutoff. So for this requirement, they wanted on the outside only of the fence, they wanted a certain area, a certain width and a certain light level, and we could show how we're guaranteeing this. And remember as well, I was talking about all the multiple beam angles available. That means that we are getting no wasted light. So no wasted light means you get an optimal use out of your illuminator, because I use this example a lot, but somebody could advertise a light goes tens of thousands of lumens, but if only 30% of them lumens are useful lumens, it's kind of pointless and a waste of energy. And yeah, important to mention also that this is absolute free of charge service to all of our partners as well. So if you're ever working on a project where it needs a lighting design, just feel free to contact us and we'll be very happy to do that for you and work with you. So I'm just going to summarize everything we've talked about now. So lighting is critical to performance of the overall system. We also looked at the different types of lights available and the benefits, how lighting can be integrated with other devices, and we also talked about the lighting design support tools available. So this comes to the end of this webinar. I hope we've got some questions.
Yeah, thanks very much, Steve. So as Steve said, we'll come to the Q&A at the end. So as I said at the start, please get your questions in. I don't think there's any there at the moment, but there was a couple from this morning, which I'll quickly go through first. But yeah, please use this opportunity to get any questions you've got to us. Just to mention before we go into those, we will make the slides available to everybody in a follow-up, and we'll also be uploading the recordings to the website, so you can access that on there. So one of the questions we had this morning, which I'll go back to first, Steve, was from Jose, who asked about whether or not you would recommend using 940 nanometers on the perimeter.
Yes, so for that one we said that 940 nanometers can be used, but the cameras typically it's less sensitive to that part of the spectrum, which means that you're going to get a reduction in distance. The reduction depends on the camera, but I would say on average you're going to get a reduction of 40 to 50% that of using 850 nanometers. So you always need to consider, I'd usually say, the next model up when you're using 940 nanometers.
Okay, thanks, Steve. I do have a question here from Tim. So Tim asks, I have a question regarding gain and how it pertains to lighting situations and recommend for analytics. I'm not sure if you need any more information there, Steve, or you can comment on that.
I probably would need some information, because obviously well, my understanding as not a camera guy is the gain would be used mainly on to boost the signal of the darker areas, but sometimes it's a compromise and causes noise. But I probably need a little bit more information on that, if that's all right.
Yeah,
so we can Tim, take that offline.
Yeah, we can take that offline and discuss that further. Another question here from Kevin, who asked, do the LEDs have a typical lifespan? Do they need to be replaced at some point?
Yeah, so we would never usually replace the individual LEDs, because it's a fully sealed IP66 unit. But I can tell you that the LEDs, they just don't fail. So the lifetime of them is 10-year plus life expectancy. I've been at Raytec for 13 years now, and I could probably count on two hands an RMA where it's been a failure of the LEDs. if something was going to fail, it would usually be something to do with a power supply component, which is still rare, but LED, it's an extremely rare occurrence for that to fail.
Okay,
but if
you.
it did fail within the warranty, sorry, we would just replace the full unit for you. That's how we would do it.
Yeah, and there's a 5-year warranty period standard on Raytec products. Thanks, Steve. So another question you have from Elkin, I hope I said that right. So Elkin asks, how far can an illuminator be from a camera height, distance and width? And is a better option on the bottom or on top of the camera?
Yeah, that's a good question. So if it depends on what kind of camera is using. So if it's a dome camera, we are recommending that it goes at least a meter below it, or it could be closer above it. So above or below is fine. Just bear in mind that if it's a dome camera, above any distance really, below it at least a meter. If it's a fixed camera, you can go directly below because it's usually in a housing that protects any light spill into the lens. You can put it above the fixed camera, but if it's too close above it, you just want to, and depending on how close to the ground you need to see, you just want to make sure there's the camera housing is not going to block any of that light. So I'd say 9 times out of 10 people are putting below the camera. And if I understand the thing about the width, I would usually recommend, if you're putting it sort of offset to the camera, have it very close, because as we mentioned, we would always match the field of view of the light to the camera lens. So obviously, especially if you're using a narrow angle and then you put the light more to the side of the camera, it's going to be there's going to become a point where it doesn't match anymore, or it loses some of the efficiency.
Okay, thanks very much.
I hope I understood that. I hope I understood that correctly. So apologies if I didn't.
Thanks, Steve. And another question from Tim. Do the PoE Raytec products include graphical user interface or GUI?
The PoE, so we got 2 types. We have the PoE. I'm not going to call it a dumb light because marketing would probably be upset with me, but we have a PoE light that is just for simple turn on and off and power up and down. And we have an IP PoE light, and that does come with the user interface included in every unit. So you can use that to control it. You can use the VMS, or you could use HTTP and that kind of stuff.
Great, thanks very much. So that's all the questions we've had so far. So unless there's any more, just a reminder, like I said earlier, that we will be making all the slides and the recordings available so you can watch back in your own time. And of course, if you've got any more questions that you want to discuss offline, we're always here and happy to help. So what we'll do is we'll say goodbye for now, but we will. Oh, there was one more question just as I'm saying that.
Good.
Let's just quickly read it. So we have different recommendation for a position of additional light next to cameras. It should be at least 1.5 meters away, as otherwise you risk getting insects and spiders in the field of view. Anything that you want to comment on that, Steve?
So could you just read that again? Said what? That it should be at least 1.5 meters.
Yeah, at least 1.5 meters away, as otherwise we risk getting insects and spiders in the field of view. So I think this is advice from elsewhere.
Yeah, that is true. I think 1.5 meters has been overcautious though, but what you're saying there is it's what we preach. It's a great message because it's a problem when it comes to the cameras with integrated IR, because the heat, especially in cooler territories, is going to attract the insects, and then you're going to get spiders building the web directly over the camera lens and things like that. But 1.5 meters, obviously, you're going to be more than safe. But I'm guessing it's just it's a conservative answer to that.
Okay, thanks very much. So we'll leave it there. Thank you very much for attending. We'll stay around for another couple of minutes just in case there are any more questions. But thanks very much for attending. Hopefully you found it useful.
Yeah, thank you for your time.
Thanks very much. Bye-bye.